Good morning, everyone. Welcome to PODS 7.01 training. It's PODS Fundamentals, and welcome. I'm Kathy Mayo, Executive Director of PODS Association, and I'm really happy to be able to continue bringing the training series to all of PODS members and those of you who are keenly interested in PODS standards and maybe are not a member. If you aren't a member, you can go to PODS website and look at the different membership areas and consider joining. It's my pleasure to welcome our trainer, Julie Parker. Many of you, if not all of you, are familiar with her. She's been our trainer. She's with Teach Me GIS. And she comes with just a ton of experience, many years in GIS, many years in the industry and in the energy sector. So welcome, Julie. It's good to have you.
Thank you. Thank you, Kathy. Hi, everyone.
I'd like to acknowledge our sponsor. Petro IT is our training sponsor, and I'd like to thank them for making this possible. And also our principal sponsor, Esri. So with that, Julie, I'm going to just turn it over to you and again, welcome everyone. Oh, I want to remind you, if you have questions, to type them into the toolbar. And also this session will be recorded and posted on PODS website.
Thanks, Kathy. Good morning, everyone. I am going to get my slides going, so bear with me just a moment. I'm going to turn my webcam off, but I can certainly still talk if need be, and also answer any questions or whatever comes up. Okay. Kathy, can you all see my screen?
I can, it looks good.
Perfect. Okay. All right, let's get started. So this is a great chapter. We're going to start dipping our collective toes, if you will, into PODS 7. So this series is all about unwrapping PODS 7. If you didn't join us last time, there is a recorded version of our very first episode. You're more than welcome to go to pods.org and download that recording so you can catch up with us. And also, the rest of the entire series is also being recorded. So if there are things that you want to revisit after you've gone through them, you can certainly download the remaining episodes too. We also have last season's up. So we did an earlier training on just some basic concepts too. So all of that is available at pods.org. So just a little bit of housekeeping here to begin with. This training is going to be about, of course, unwrapping PODS 7. We're going to start peeling the onion, as it were, on PODS 7. And in this particular unit, we're really going to begin that series. So we're going to be talking about the PODS 7 data model itself and some of its component databases, but we're also going to compare PODS 7 with some of the previous PODS models. For those of you that are familiar with PODS already, and maybe you've even got an installation right now of PODS in your organization, this may help you connect a little bit better to PODS 7. So the intended audience for this is for GIS and IT professionals, folks that are new to the pipeline industry, and those that have little or no exposure to PODS. But also in this training, we're speaking to those who don't have much exposure to PODS 7. So perhaps that you already have an installation in-house of a previous version of PODS, and you're maybe contemplating upgrading and making the move to PODS 7. This training is also for you too, because you're new to PODS 7, and it is quite a departure, as you'll see from the versions that came before it. So this is the second unit of of 6 units. And you can see in the slide here, we are in the second unit, Unwrapping PODS Part 1. The rest of the units, 3 through 6, are upcoming. We'll be doing these weekly, and you can see how the rest of the series is going to unfold. So in our last session, just to briefly recap, in our last session, we talked about the importance of your pipeline data as an asset to your organization and what that means in terms of treating your data as an asset. We noted that PODS is shaped by industry standards, and it's a robust and very flexible and proven data model for managing pipeline data. We also introduced you to POD's newest data model, PODS 7, and we talked about the fact that PODS 7 can be downloaded and deployed and customized and used to fit the needs of any pipeline operator. Lastly, we talked about how PODS standards and the data models promote data reliability, workflow efficiency, safety and risk management, as well as regulatory compliance. So today we're going to continue this PODS 7 topic by talking about the drivers that are shaping PODS 7 and the fact that relational databases are the foundational building block for the data model. If you're not sure what a relational database is, don't worry, we're going to get there. For those of you that are well seasoned, just bear with us while we bring everybody else along. So we'll talk about the uniqueness of PODS 7 as compared with these previous model versions and highlight some of the key differences between a data model, data tables within the databases, and the schemas. So this is really a kind of a pivotal presentation today because we're starting to take baby steps away from the previous PODS models and into PODS 7. So here's what this is going to look like then. We'll talk about the PODS schema, the PODS 7 schema. And we're going to go through a series of slides that are making some comparisons between PODS 7 and legacy models. So we'll talk about some of the key advances that the PODS models have adopted as they have grown and matured over time. And then we're going to talk about what is different about PODS 7. And we're going to start taking our first looks at the PODS 7 data model. We'll also talk about the fact that the PODS model, all of the PODS models, are comprised of the essential building blocks of the data, which are the databases themselves, the relational databases. And so we're going to talk about that too. So this is a pretty full session. There's lots of good stuff to get to. So I want to remind you that if you have questions as we're going through this, please take a moment and open your chat and type in a question. Kathy will be moderating the chat, and if we can't answer the question during this time, she will definitely be in touch with you and providing an answer to your questions. So don't be shy about asking questions. So really, our early learning objectives here for this unit are to simply become familiar with the PODS 7 data model. I don't know how many of you have actually seen the model yet. So we're going to become a little more familiar, and then we're going to get a lot more familiar over the next several units. We're going to learn some of the general data management terms and concepts that are relating to the PODS 7 model. We're going to differentiate then too between previous versions of PODS. And also, we're going to explore what is setting PODS 7 apart from the previous versions. I think by the end of this unit, you'll have a pretty clear idea. And maybe have even learned some things. If you're an old PODS user, you may learn some things about the inner workings of the models that you've had experience with and how these these changes have led to pod 7. So you might remember this graphic from our first presentation, but it's a good one because it's really basic, and there's a lot you can do with this in terms of just thinking about pipeline assets in general and the whole ecosystem that they exist in. So you've got all these assets. There's locations, there's surroundings, there's affiliated information with each one of these physical assets that you see in the graphic. And so the question is, how do you convert all of this information and all the ancillary information into an information system? How do you not only document the location and the specifics of each and every type of asset here, and then how do you manage it over time? How do you perhaps do modeling with it, predictions for the future, and so on and so forth? So today we're going to zoom out and holistically view the PODS data model and its various components. So we're going to expand upon Unit 1, where we just introduced the data model. But we're going to actually dig deeper into the data management aspects of PODS and introduce you to PODS' latest data model, which is, of course, PODS 7. But first, let's go back to this graphic for just a second. What do you see? You certainly see pipelines, associated equipment, and other assets, but what kinds of assets? Are they production assets, monitoring assets? Are they marketing and sales assets, transmission assets, mechanical, and so on? All of these assets exist on the Earth's surface and in actual areas. So where are the geographic boundaries that constrain or perhaps even lead the spread or development of these assets across an area? So holistically, what you do see in this graphic is connectivity. What you see is a geographic area that contains many different types of assets, and yet all of these assets are connected. And that's really the whole point of PODS, is having the appropriate model to help store information about widely ranging types of assets across wide spaces of the world, and holistically seeing this connectivity wherever it happens to be, seeing a complete network of pipeline and production and equipment and geography all brought together. So that's a pretty tall order for an information system. But PODS, and as you'll see in a few minutes as we look at some of these other versions, PODS is just meant for this. It's ideally suited to this complexity and wide geographic existence of pipeline infrastructure. So, picking apart some of the things that we may not have seen in the graphic on the previous slide, how do you even begin to design some sort of container for all of this different kinds of data? So the assets themselves have to be stored, the location of that asset, the type of that asset, but you've also got to be able to store a whole lot of other descriptive information about each and every piece of this infrastructure. And you need to have connectivity between these assets because they don't all exist in a vacuum, right? They're all interconnected. So how do you build a container that is this comprehensive, yet all connected together? So it is about the container, to be sure. Modeling is actually taking place then within kind of a contained environment. It's an idealized environment, but it's meant to mimic the real assets themselves and all the complexity that they have. But it's not just about the data. It's also about the information that's included in this data. So you're only going to get good information if your data is good, right? So you have to make sure that your data is organized, that it is organized in such a way that it's easy for you to ask questions of this data and get answers that are believable and that you can rely on in decision making. So you have to make sure that you have a good data model, and you also need to make sure that within that data model, the information about the assets in that model are true and correct and robust. So your data then should be organized in a common language and in a tabular design, ideally in rows and columns of data, lots of tables maybe. And if this is done with veracity, then you can rely on the fact that your data is going to provide truth and meaning to you and your organization. It's also going to illuminate and perhaps emphasize relationships between data elements. And it's also going to provide you with great opportunities for growth. Maybe you'll see relationships you didn't see before. Maybe you can optimize the performance of your assets. Perhaps you can have greater reliance and credibility of your data so that you can make decisions off of it and feel good about those decisions that you make. So it's important then that data determine the truth. Only though if that data is based in truth, based on standards, governance, good data management practice, quality of the data. And then lastly, systems of record. You've got to have incoming data into your pipeline model that you can rely on and that you know are already systems of record or authoritative sources. So bad decisions come from bad data, right? So we want to make sure that you have a strong database that's built on good quality data. So this is a pretty tall order, right? When you start thinking about all of this data, all of these assets, all of the relationships between these assets, back to our original question then, how do you design a container for all of this data, knowing the pressure that it's under? Not only do we have volumes of data, but we also have lots of trust that needs to be instilled in this data. You need to make sure that it does become your authoritative source. Your data is the place where people go in your organization when they need to make a decision or locate an asset or check some report or something to do with your data. So it's important, but you can't just have a group of files out there holding this information because it's just not going to adequately reflect the nature of the PODS network or the pipeline network. So this is really where PODS comes in. You have the PODS data model then, which you're going to need. The PODS data model with its logical groups of tables that are connected, that are going to help answer a lot of the questions here. It's going to provide the tools then to answer questions such as, what's the quality of this data? How reliable is it? Does it have a good governance? Can we use this data to make key decisions with? Is it well organized, etc.? So the answer to our question then, how do you design a container for all this mission critical data, is tables. And tables meaning data tables. So in essence, in order to adequately do this, you're going to have lots of tables, many tables that are representing information about each one of the asset types that we've been talking about and that you saw in the graphic above. So you're creating all of this data, but like I said before, it doesn't exist in a vacuum. There has to be connectivity and relationship, right? We know that along a pipeline, there are many different assets that are connected or related to that segment of pipeline, right? So the data has to relate and connect too. So in this case, then, you've got logically related tables. And then you've got some other decisions that you're going to need to make. We know we need to have the logically related tables, but now if you're thinking about for the first time implementing pods or any data model for that matter, you've got to make some decisions about what data should be stored, how should the tables be organized, what kinds of information is needed from this data, how do we ask questions of it, and how should we create relationships between the various tables and then govern them to make sure that they're correct and that they're long-standing. How will our users derive meaning from this data? Lots of questions about all of this. So you need a data model, and that's where PODS comes in. So this is an example of a previous PODS model. And what you're seeing here is a station center line. So this is a tabular representation of how you would take information about a center line and establish data tables that are related to each other and also provide connectivity to other databases that can feed into the station center lines. So it's because of relational databases that we can build out something like a PODS data model. So relational databases are an old concept. They certainly are alive and well in POD 7, but you're going to see as we walk through some of the old versions of PODS models in a few minutes, you'll see that relational databases have always been the basic building block of the PODS data models. So these related tables then are the essential underpinning of the data model, regardless of the vintage. It's always, if you lift the cover on it, you're always going to see related data tables. These databases and the relationships between them are the engine behind the PODS data model. So in this unit, we'll gain a better understanding of relational databases. If you're not familiar with them, you'll learn a little bit more about how they work and how they function within PODS. So just take a moment to examine this graphic. We're going to talk more about relational databases throughout the rest of this segment, but just examine the graphic. If you can see it from where you are, look at the types of data that is in each one of these tables. And then notice the lines or arrows that exist between the tables. These are symbolic of the relationships between various tables. So this is connoting then relational databases. So some of you might be going, okay, I'm starting to get this, but I don't even really understand what a database actually is. So let's just do a quick checkup here and make sure that everybody's starting off from the same place. Earlier, I mentioned that ideally data is going to be stored in some type of structure, ideally with rows and columns of data. Why is that? Well, it certainly makes it easy for managing and sorting data and querying data, and certainly being able to sort data and understand the nature of what information that data is trying to communicate. So just a quick check back here on what is a database. So it's a collection of data stored in related tables. You can read on the slide, I won't belabor that, but basically databases are governed by a database management system. And you've probably heard of names like SQL and PostgreSQL and SQL Server, Oracle, and so on and so forth. These are database management systems, and their role is to be the storage, retrieval, and update authority for databases. So they're managing how the databases relate to each other, what happens when new data comes in to a database, what happens when people request data from them to get information or create reports. That's the job of a database management system. Underpinning and ancillary to a database, it's good practice to have data dictionaries. So data dictionaries are a type of what we call metadata, data about your data. And this actually spells out what the contents of a database are. So you can see in this particular example, you see the data dictionaries, you can see the area highlighted in red. I can see the name of a field in the database. In this case, it's PL_company name. It's going to be a string type of field, which is a data type we won't have to get into right now. It can hold up to 75 characters of information. And then the precision and scale we can skip over for now. It's not important for us to spend time on that for now. Allowing null values. Is it permissible for someone to leave that field blank if they're entering new data? Can they leave that field blank? Can it be 0 or can it be blank? And if it's false, that means no, it has to be populated. And then there's a description of what actually goes in that field of data. So you can imagine in a data model, there are so many data tables, but each and every one of the items within that data table have to be documented. And you'll find, if you haven't looked at the documentation for Pod 7 or previous data models, you'll find the data dictionaries exist for every table. The nice thing is that if you're using these data dictionaries that PODS provides, is as you're populating your own databases with your own information, if you're using the data structures and the data dictionaries that PODS supplies, then you're automatically meeting the PODS standards for Pod 7. So you're already creating PODS compliant data. So we've talked about databases as if they are flat tables of information, rows and columns of information, but a relational database takes this then to a whole new level. So in a relational database, the database or the table has undergone a normalization process during which the tables and the relationships and the rules that establish their relationships are all codified. And this makes the process, or it makes the database as a result, function efficiently. So it's important that you'll have information stored. You don't want to keep repeating the same information. You want to do this in a thoughtful way. You want to be able to have operators, for example, in an operator table. You want to have pipelines in a pipeline table, meters in a meter table, and use the relationships or the connections that can be established between those tables to glean more information about that data, that asset. So if you've ever clicked on if you use GIS and you've ever clicked identify, for example, and you click on a feature in a map, and a little table opens up and it reveals all the information about that feature you just clicked on. That all of that information you're seeing may be coming from multiple related databases. It may not exist all in one table, but it's an efficient way to store data and allow connections to be made between tables that should be related together. So you can see there's a certain connectivity then that exists between tables. We're going to dive a little deeper into this. So I guess at the bottom line here, it's an efficiency thing. You don't need to store information about an operator, for example, in multiple tables. It's only going to be in one table. But for other tables, like a pipeline table that needs that information about an operator, guess what? They can borrow it from the operator table. So that's really the bottom line of why things are set up in this way. So in our next slide, we dive a little deeper into this, and we can see a little bit more about how the inner workings are working here with the relational databases. So you can see the primary key denoted here with the orange PK in the middle of each box here. You can see the primary key is a unique ID field. So oftentimes you may have seen this before in your data, you'll see something that's like a UID or a GUID. This is a unique identifier, and it's super important because it is truly unique, and it's never blank or never null, never has a zero in it, and it never changes no matter what types of edits are done to that particular record or data. It never loses its ID. It's ID'd for life. So this function of a unique ID is actually fulfilled by using GUIDs, GUID, if you've ever seen that. It stands for Globally Unique Identifier. So they're a lot more robust than a simple unique ID because they're extremely large numbers that are guaranteed to be unique, which is terribly important in this case because we want to make sure that everything is unique so that we have proper connections that will identify every single component in a pipeline network. And if you think about it, if you work directly with pipeline data or you're working in a field capacity, think about all the little components of your pipeline being encapsulated into a bunch of fields and data tables. There has to be uniqueness there so that things stay orderly and that you can rely on the information that you get back on it. So the GUIDs then, their job is to ensure that the pod's relational databases always have unique primary keys. So these primary keys are really the main connectors then that allow relational tables to hook up. So they look for a match. So for example, the operator table, you can see the primary key is the UID field. Well, the pipeline also has a UID field that's a primary key, but its primary key is related to the pipeline and not the operator. However, if you look down below, if you follow the line through the primary key next door to the pipeline table, you'll see the op-id field, and it's a match. So its operator ID is going to match up with the UID that is a primary key in the operator table. Thus, the relationship is submitted. So when you've got thousands of operators and thousands of pipeline systems, you can be assured that when operators are matched to pipeline segments, those operator IDs are relating to the UID found in the operator table. So they're always unique, and they have to be unique so that there's one and only one match. So foreign keys, we won't go into so much detail right now, but foreign keys are not necessarily unique values. In fact, you may see them multiple times, replicated multiple times throughout a database or a table. But typically, they also point to some other primary key table. So in this case, you can kind of see the yellow foreign keys. So you can see pipe ID, for example, is relating back as a foreign key. It relates back to the UID in the pipeline table. It's kind of confusing, but if you get a little used to it, or get some practice with it, you'll understand the concept. And maybe this next slide helps solidify things a little bit more. So this is a section here, the station centerline section, and you can see how this actually plays out in the PODS world. So let's look at the series marked in green. The series here, table, is related back to the measure table. And what do you see at that juncture? So the areas highlighted in green rectangles there are the GUID fields, the unique identifier fields that are relating those two tables back together. And there's one and only one match for those records. Another example is the line being related to its route. Same thing, you'll see the GUID fields there relating between the route and the line tables. So you can kind of start getting the idea, I hope, that these unique identifiers are actually the cement that actually solidify the relationships between tables in the data model and give you the connectivity that you need, especially when you're doing things like measuring or modeling or just querying. So we'll leave this for now. We'll come back to it. You'll hear this language again, I'm sure. You'll certainly come across it in the PODS 7 documentation, and you can learn a lot more too about these terms. But I want to make sure we're clear then on the difference between a data model and a database. So when we talk about PODS 7, or we talk about PODS 3 or 4 or 6, these are data models. And inherent in these data models are the connections between the data. The data model is going to define what tables get connected together, how data is going to be accessed and processed and updated, and so on. So there's really no data stored in the data model, but it's the blueprint, if you will, for how that database and data within it are going to act, how it should be treated. Where are the connections between tables, for example? What happens when data gets updated? How does that new information, if we change the name of an asset, for example, or we do some maintenance and we replace a part, how does that new information permeate the data model and get passed on to the other pieces in your database that need that information too? So the data model is regulating all of that stuff. So that's why we have all these different versions of the PODS data models. As data proliferates in our systems, we need more new data models that take advantages of advances in data storage and data processing to help make sure that we can maintain pipeline databases the way they should be. So the database then is just a physical implementation. It's like a blueprint. The data model is your blueprint. The database is actually the physical manifestation of that data model. If the data model says a certain table is built in this structure and it contains these items of data in it, then the database is that physical implementation of that directive or that plan. So the database then controls and is the central repository then for all of the data. Ideally, this PODS database is your system of record, or it becomes your system of record, your authoritative source for all of your pipeline data. So let's dive a little deeper into this. The data model then is defining how data is stored, accessed, processed, and so on, connected. So it's providing then the organizational and the constructural, the conceptual model of data relationships. You'll find as we begin looking at the POD 7 data model, you will find that we're going to talk more about the 3 types of data models. So there's not just one. There's a conceptual model that is kind of like an overview. Think of a house plan. I'm thinking house plans right now because I'm getting ready to build a house. And so I'm thinking, I'm looking at my house plan and I may want to make changes to it. I can see though that my house plan has all the stuff that I need to live comfortably in that structure. It has plumbing, it has electrical, it has a roof, it has doors and windows. And so at a conceptual level, I can see and understand that this particular floor plan has everything I need. The logical model is probably going to be something my contractor's concerned with though, because he's going to look at more details. What are the elevations of the land that this property is going to be on? What are the details around electrical wiring and insulation and foundation size and all this kind of stuff. So we're getting a little bit more information about the model of my house, or in this case, thinking about pods, a little bit more detailed model that's actually going to start spelling out the rules of the road here for how these data tables are going to connect together. And the rules are oftentimes based on standards. So it begins to start spelling out more of the details about how this POD 7 model, for example, should be implemented and how its inner workings exist together. Lastly is the physical model. So this is a finished model. This is the model as it would exist in your specific individual platform. So one implementation at one company is not going to be identical to another company's final manifestation of POD 7. Everybody may be on the POD 7 data model, but because it's flexible and extensible, it's going to be tailored to fit their exact business situation and needs. And so physically, when my house is all built, the conceptual and logical elements of the model or my house plan, for example, have resulted in a physical structure. It's the same thing here. It's conceptual, logical models that are informing and creating and specifying how that physical manifestation of pods is going to exist in your particular circumstances and computing environment. So let's look then next. I've been talking about looking at some of these other models. Let's just take a quick look. Here are some of the earliest models. These are what we would call conceptual models. And I'm sure the print is way too tiny for you all to read. It certainly is for me. But just get an idea of the overall structure. The colors that you see here within the models themselves just to help connote the grouping of like types of assets, like the pipeline facility, for example, in PODS 2 is all shaded kind of a turquoise blue. The core tables in these early versions are all shaded in yellow. So these are the tables that you have to have in your implementation. There's certainly flexibility in the other parts of pods, but there's a set of core tables, for example, in these versions that you had to have if you were going to use pods. So you can see in pods 2 and 3, there's not a whole lot of difference technically between these, except to say that there's a lot of more information being stored in a pods 3.2 model than a PODS 2.0 model. I mean, you can see there's many more tables, and they're all relational databases, right? They're all related tables. They're grouped together by kind, but they're also related to each other and also to other components that may be, you may have pipeline information then related to production or regulatory groupings. So the relationships, the underlying conceptual model here is just giving you a schematic of what this data model can hold and how, at a very minor level or a very high level, how things are connected together. Here's PODS 4. This is one of the most popular models. It still holds even more data than the previous versions did, 2 and 3. So the groupings then, just like we saw before, the colored boxes are demarcating the groups of data tables, like locations and regulatory and compliance and cathodic protection and events and center lines and so on. There's a place for just about every component of a pipeline at this point. At PODS 5, things start to get a little interesting. So this is the conceptual model of 5.0. And in this version, this is where we first start seeing that GUIDs are used, GUIDs are used rather than integers for creating unique IDs. And it's obvious when you compare this model with the previous models, you had to have GUIDs at this point because you're storing so much more data in this version than you were in previous versions, and you've got to have a way to keep these relationships intact and related correctly. So this is the first time then you start seeing the GUIDs being used within the database, and also using those GUIDs as primary keys then for relating database tables together. So PODS 5 also marks the beginning of spatially enabling the model. So beforehand, there really wasn't a there wasn't a real geographic or spatial awareness modeled into the structure. Of course, there was location information stored, but there wasn't the model, and all of its components weren't spatially aware until point 5, or excuse me, at 5.0. So it's designed to work exclusively with, at this time, Esri geodatabases. So therefore, it's also a major step apart from previous PODS models, which were completely agnostic. This one was capitalizing on the growing movement in the industry towards spatializing the model, and it has continued ever since. Let's take a look at Pod 6. Still more tables, and another movement towards not just enhancing the types and amounts of data that are stored, but there's two major things then that really happened at 6. First, you had a choice of installing either a Pod 6 relational database, such as Oracle or SQL Server, which we talked about earlier as these database management systems. So depending on what you had in your organization, you could, if you had Oracle Spatial, for example, or Oracle or SQL Server, you could have a separate, more in tune kind of Pod 6 that fit your environment. Or you could use PODS Esri Spatial. So this is where the model is linearly referenced. We're going to talk about linear referencing, but it's basically the spatial awareness that is inherent in the pipeline model. So it was able then to, because it was spatialized, it could be visualized in any GIS platform. Most commonly, it was Esri's products, right? So pipeline components then were treated as events that connected to the centerline tables, and that's what allowed them to become located spatially on a map. So a lot of us today take for granted that you can see your pipelines in a network over space, in space. Know exact locations of certain assets along those lines. That did not always exist. And so at Pod 6, the spatialness, I'll say, if I can invent my own word, is becoming apparent, and it's becoming prolific. So secondly, the model at this point, because it has grown so large, has become modularized. And what that means is that, yes, we had all of these tables. So we had a whole big set of tables sharing common functions. And at this point, there's about 26 modules in all, including the one core module that was mandatory. But at this point, you didn't have to install and implement the entire PODS model if that did not fit your organizational needs. This is a big change. So at this point, because of the modularity of this model, once you have installed the core modules, such as line and route, series, station points, I think event ranges and coordinates, once you've gotten some of those core tables installed and populated, then you could choose other tables and other table groupings to install into your implementation. So you didn't have to install everything that you see here. It was becoming more customizable. So it brought several great benefits then to the PODS community. Users could install and use only the modules they wanted. They could also enjoy the ability to receive updates from PODS Association. So you could also have, if PODS Association updated certain modules, in the data model, you could accept those key module updates, but only if they were fitting your implementation. So you didn't necessarily have to take all of the updates that were being done to a database. You had a much more customized way of updating your particular implementation. You also had something called versioning. So you could determine there was a way then of versioning updates to the pods modules. So releases now were numbered, they were classified as either major or minor revisions, and you could react accordingly to your organization's needs as to whether you made a lot of these updates. But you could see how if you made one update in an area, because of versioning, you could see how that update might affect other connected tables and make a more informed decision on whether you chose to implement or not. So it's probably more information than you need at this level, but I think it's really interesting to see how this has changed over time. So bam, here we are, pod 7. This is the conceptual module of pod 7. Right away, it's completely different looking, isn't it? So we've taken this little journey together over these last few slides to kind of pay an homage to all of the updates and the improvements that have been made over the years of pods to get to where we are today with pod 7. So you can see by looking at these slides the progress that's been made and how robust the model has become over time. So here we are at pod 7, and this is going to mark the beginning of the transition for this series from talking about previous models and showing previous models to focusing solely on pod 7. As you look at this schematic, this data model, conceptual model, you can see there's a lot of differences between, say, a pod 6 and a pods 5, or even a pods 2 or 3, compared to the model that you see before you. And don't let it scare you. It's every bit as robust, if not more so, certainly more so, I think, than the most recent pods models. It's just designed a little bit differently, and it's meant actually to be simpler and easier to understand than some of the other models that we've had historically. Pod 7 was developed with some of these objectives in mind. First of all, support for a worldwide deployment. You've got to have a common language, if you will, a common data language across the world, because our pipeline infrastructure span the world today. So you need to have a model that is going to be able to support pipelines and pipeline infrastructures and companies wherever they are around the globe. The model needs to respond to new and changing business requirements, which, as you've seen with the regulatory climate, that's changed a lot over the years, and technology is always changing. It's also there to optimize performance in the face of increasing data volumes, varieties of data, and the velocity, the speed at which this data is coming into you. PODS also wanted to establish a single logical model that could be deployed as a vendor-neutral, GIS-agnostic relational database management system specific physical model. So it's highly customizable then to your organization. And lastly, it's development and stewardship of an open interchange specification for sharing data and transferring data and schema and data validation. So there's lots to look forward to as we begin to move into pod 7 in great detail now in future sessions. If you're sitting there and you're kind of biting your nails and you're thinking, wow, I don't know, I'm on pod 6 and I'm not sure there's a place for all of my stuff in this new model. It looks great, but where am I going to put this or that? Don't worry. There is a place for your data in existing pods. In pod 7, there is a place for your data. So looking here at the pipeline hierarchy, this kind of is the new look of some of the core models or the core modules that existed in previous models. So you can see line and route and series and station point. These are some of the core components of the model. They're still there and they still relate to each other. So you can see, looking at the lines that are connecting these individual modules and tables, you can see not only that they're related, but you can also understand more about the type of relationship that exists between these data elements. We're going to pop the top on all of this in the coming series, the rest of these units. Our location model, of course, it's still spatially aware. You don't need Esri GIS to model or store this information. You can do it with a standard spatial data type in a relational database, but it doesn't have to be Esri. But we find that many people have deployed Esri software to manage or help manage their pipeline data in concert with pods, and so it's still a natural fit. So you're still going to need software because it is spatially aware, whether it's Esri or Oracle Spatial or whatever flavor GIS you go to. You're still going to need some way of managing the locational spatial aspect of your data. And Pod 7 is customizable to whatever decision you make. So as we close out, I want to leave you with some key differences between Pod 7 and previous models. What's really different? As you can see, it's been completely redesigned. I think you would also agree that it is very streamlined. There's not a lot of fluff there. It's certainly been redesigned with a new approach in mind for managing modules, but also not managing them to the extent where they're locked down. They're highly customizable to your business. So it means that you can extend and customize the modules to make them fit exactly your needs. There's a new data exchange specification that's been implemented in Pod 7. It's making it simpler to increase the readability of the data, the compatibility of your data, as well as aid in the customization of your data modules. Lastly, if you are a PODS member already, you can go and download the documentation for Pod 7 and begin getting familiar with Pod 7 at a much deeper level. You'll find, I think, I've relied heavily on the PODS documentation for this work and this project, and so I can tell you that the documentation is very thorough and very easy to understand and access. All of this then is available through pods.org. So I'll leave you. We've run a few minutes over, but this is such an important unit. I really didn't want to breeze through it too fast, but I won't go through each and every option here on why pods, but I urge you to download this recording. Look through Pod 7. Why? If you're trying to figure out how to build the rationale for upgrading to Pod 7, or you're trying to make the decision about Pod 7, there's some good information here, just some thoughts on why you might want to make this change. It'll help you certainly in building the business case for implementing Pod 7. So I'll leave you with these last two slides. But the final thought here is that like all the previous models, Pod 7 is designed to be your system of record for your pipelines, center lines, and all of your assets that are involved in the safe, transport of product wherever they happen to be in the world. So it's important then to leave you with that thought, and also just briefly summarize in our closing minute here on what we've covered here. It was a pretty beefy unit this time, so if you didn't catch everything, or if I had to move faster than you would have liked, please download this and go back through it. But basically, we've talked then about Pod 7 being a complete redesign of PODS models. And you can see there's a stark difference between the Pod 7 conceptual model and the previous ones. Of course, just like in previous versions, though, the relational databases are still the essential building blocks of Pod 7. That's not going to change. Data models are still going to be the mechanism or the structure then that defines the database connections between tables, how data are stored, and how they're processed. Databases are the outgrowth then of the data model. So if you go to Pod 7, your individual databases will be the physical results of implementing the Pod 7 data model. And I think the last one really doesn't need to be said, but I think you saw as we went through those slides of the other versions, the previous versions, over time the PODS data models have certainly evolved considerably. But they haven't evolved just for the sake of change. They're trying to keep step or even be ahead of the changing needs of pipeline operators and professionals across the globe. So it's important to note that change is not easy. However, it's necessary, particularly in this industry that we all work in. So with that, I'm going to end this unit. We are, like I said, I apologize, I'm a little bit over, but certainly if you have lingering questions in your mind, please fill out something in the chat to Kathy, and she'll make sure that we get an answer back to you. With that, I want to say thank you, and I appreciate your time and attention, and we'll talk next week.
Thank you so much, Julie. It certainly is a beefy unit. And while some of the information, I think on the surface is review for probably many who are here, what I find is there are different ways to lay it out. And as our PODS data model has evolved, there are different ways to talk about it. And you certainly, I think, offered a really good explanation of that journey. So I appreciate that. And in fact, we got feedback from one of the attendees that stated just that. You know, it was a great example of the conceptual, logical, physical data model explanation. And as I've heard it, you know, a number of times and led this organization as executive director, I find I still grab the data model. So I reached for it here to really look into one of the questions that was posed, and that is PODS supported. One of the questions that came in is we support the relational database model for structured data, but how do we treat the vast amounts of unstructured data? And you will find a table for that in metadata for documentation. So there you can attach PDFs, text files, photos, all that kind of thing. So that was one question that came in. Another one that came in, and again, this is from Paul Murray, who has left, and I'm going to make sure that he gets answers, written answers to his questions, but is PODS considering adapting beyond the traditional relational database model approach embodied by different database technologies such as in-memory database, Hadoop, NoSQL databases, and virtualized or federated databases? I don't know the answer to that. I do know that our Pod 7 chairs have talked about NoSQL and the fact that we do provide many approaches to the physical data model. You know, I'm going to ask a couple of the board members if either I see Dale on there, Eugene, and Chad Haltman. Do any of you guys have a better answer than I can provide? And I'm going to add that I'll certainly get this answer and post it. I'm trying to unmute folks, and I guess I'm not that clever. I'll get that answer for you. I know that the 7 is designed to be highly flexible, and it has been addressed within our committee, but the exact answer, I will seek that for you. Are there any tools, scripts available to migrate previous versions of PODS 7? That's where operators and others really need to work with PODS member vendor community, and they can help you with that. And we'll certainly be posting the link to this Unit 2 training series. So you can look for that on PODS website, and I'll try to get a direct mail out to everybody too to let you know when that's available. So with that, I think we're going to close. Thank you, Julie.
Can I ask
Thank
one
you all for
question?
attending. Sure.
Just sorry, one question came to mind. Is it possible for PODS, for non-members of PODS, to download a poster of PODS 7, of the conceptual model?
I think that's available in the secured area of our website, but I will check for that.
Okay,
I'll
thanks.
verify where it is, because I
Okay.
do know it is. Again, PODS data models are available to members only. And again, I encourage you who are not members to really take a serious look at becoming a member of PODS. This is how we get this good work done, is through our membership. And it's volunteer driven. Our volunteer group has developed what you see in PODS 7 and all the documentation, and we do it through the support of all of our members. So, but I will check to see if the logical conceptual model is available directly.
Just that poster.
Certainly.
I know it used to be, but I don't know if it is still that way. So I know that might be something that people might be wondering about.
Great. A question, is it easy to transfer data from PODS 5.3 to 7? That's a complicated answer. It really depends on your skills and experience pool within your company. It's not for the faint of heart, but I, again, encourage you to take a look at all of the documentation available with PODS 7. It's comprehensive. It does talk a person through, how to do that or what the approach is, but it really requires definitely some technical skill to do that. And again, that's why we have a robust PODS vendor community. I think that covers a lot of these questions. So with that, we're going to conclude. Please sign up for Unit 3. We're going to continue this unpacking PODS 7 a week from today. So I encourage you to do that. Thank you for attending. I'd like to also thank our sponsor again, Petro IT. They're our training sponsor for this 6-unit series, and we really couldn't do it without their support. I'd also like to thank Esri, who is our principal sponsor. So with that, we'll close for the day, and thank you very much.